We will listen to the serverless first presentation by Adrian. So Adrian, the stage is yours.
Thank you very much. I'm glad to be back at Craft Conference. I'm calling in from California rather than being there in Budapest, so hopefully soon we can all be back together. But today I'm going to talk a little bit about serverless, but I'm going to start off by talking about a new role that I have. So I joined Amazon about 4.5 years ago in AWS and worked a lot on open source and on a lot of talking about digital transformation. And if we think about, there we go, get my clicker to work. Okay, if we think about digital transformation, this was driven by customers connecting directly to the internet and connecting directly to the business via mobile and web-based apps. And new business models appeared due to that. Things like Amazon, Netflix, Uber, Facebook, these are all things that were enabled as part of digital transformation. And then the entire industry, in order to compete with these new business models, had to learn how to innovate. And we figured out cloud, DevOps, microservices as the tools we use to work on our digital transformation. And I think at this point, we're at least 10 years into this from my perspective. This is pretty well understood, and it's time for me to move on and find something interesting to do that's new and that's emerging. What I care about right now is sustainability transformation. This is a topic that's emerging. It's not that well understood, and many people are starting to think about it. So what we need to do is measure and reduce the environmental impact and carbon footprint of our organizations. We're getting new pressures from customers, from markets, and from legislation. We need to instrument and reinvent the entire product line of the company in many cases, but we're still going to be using cloud and DevOps and microservices and things like that to go faster. And then we'll be doing well-architected serverless applications to be particularly efficient. And so I'm going to talk a bit more about sustainability, but I think that serverless has a role as the most efficient way you can build an application. And I say this is emerging. We don't have all the answers yet. There's a lot of things still to come. So I'm exploring this as a new area. If we think about what AWS is responsible for, then it's responsible for obviously security of the cloud and a few things like that, but it's also responsible for sustainability of the cloud. So what that means is that AWS builds its global infrastructure. We optimize how we build our servers, cooling, the water, the waste we produce. We build our data centers to be more carbon-free and more green. We are sourcing electric supply that's renewable, and we're looking at building materials and starting to use more renewable building materials. The customer builds their application on top of that, and there's a bunch of things the customer is responsible for. But if you build a serverless application, some of those things actually are still AWS responsibility. So customers are always going to be responsible for the data design and usage, software application design, and code efficiency. If you build serverless, then data storage, utilization, scaling, and platform deployments. And that's part of scaling. Those are things which are you can choose. Do you want the cloud to do them for you in a serverless model, or do you want to do them yourself? And I think by just having less to worry about and letting AWS work on optimizing these things is going to make it better. If you take a typical on-premise data center and compare it with the cloud, we've got some analysis that shows from a few years ago that we're 3.6 times more energy efficient, largely because of high utilization and more efficient systems. And then because we're running a higher proportion of renewable energy, we also end up with an 88% lower carbon footprint just from taking exactly the same workload and moving that to a cloud. Now, if we look at what's happening at Amazon, we made an announcement almost 2 years ago now with the climate pledge. And you have to understand that there's this thing called the Paris Agreement that came out a few years ago, which basically said that we need to find a way to be carbon neutral by 2050. And companies have been signing up to say, okay, I have a path that leads me to being carbon neutral in 2050. Now, think about that. Like, what will you be doing in 2050? Like, if I'm the executive of a company and says, I will give you a bonus if you can be carbon neutral by 2050, and you look at that and go, like, I'm very unlikely to be working for this company in 2050. Right? I will be happy. I'll be retired. I'll still be alive in 2050 is my goal. So there's a problem here that this is too far in the future to really be an actionable thing that people can plan for and think about. And even with that, it's still not aggressive enough in terms of the goal itself. So what Amazon did, combining with an organization called Global Optimism, is we said we're going to be net zero carbon by 2040, 10 years before, and we're going to try and find other people that will agree to be more aggressive than the Paris Agreement, come in by 2040, and also have interim goals which get you there. So 2040 is still too far in the future. Most people will not be working for the same company in 2040. So let's wind it back to what we can do in 2030. Still a long time away, but maybe 2025. Now you've got something that's at least plausible to be working on in the next 4 years. And what Amazon is committed to is 100% renewable energy by 2025 for all of Amazon. This is not just AWS. This isn't just the data centers. This is all of the fulfillment centers, all the shipping. We're going to be moving over the next few years. Our trucks will become electric, so that power needs to become renewable. The heating in our buildings will move to electric, so that power. So the robots we use for delivery, all of these things, we're going to be increasing the proportion of the energy that we get from electricity over the next few years, at the same time switching that to renewable electricity. So this is a big commitment. It's a long way to go because we have to buy a really large amount of energy to cover all of these cases. And we're doing it at an Amazon level rather than AWS level because it's hard to separate out where the boundaries are. We have a lot of shared buildings, a lot of shared capabilities where it just makes sense to do it as a single top-level goal for the whole company. We've also started a $2 billion climate pledge fund. This is funding startups who can help us build this and get there. One of the companies we invested in is called Carbon Cure. They make low carbon intensity concrete. We're looking at putting out buildings that use concrete. Using the cement that's in the concrete is typically a big emitter of carbon, but if you do it right, you can capture that carbon and then inject it back into the concrete as you mix it. So there's a way to build low carbon, low steel. Buildings are something that's really important. It turns out every company has buildings, and it's something that every company should be thinking about. How do we get the carbon out of the buildings as we build them, and out of the heating and operation of those buildings as we run them? Anyway, if we look at renewable energy, Amazon is now the largest corporate purchaser of renewable energy globally. And in Europe, we're also the largest as well. We have 8.5 gigawatts of total renewable capacity and 2.5 gigawatts in Europe. Hundreds of projects in total. 71 of them are utility scale. This is sort of like a 100 megawatt wind farm or solar farm, that kind of thing. We've got our first battery storage capability has just been announced. And then many of our buildings, we have solar panels on the roof on our fulfillment centers and office buildings. So this is a huge purchase, and we still have more to buy. We aren't at 100% yet, but this is just because of the scale of Amazon. Amazon is well over 1 million people, and it's one of the largest and fastest growing companies in the world. And we have a lot of physical footprint. We move things around, and this consumes a lot more of the energy than the computing footprint from AWS and the servers we use. So that's just to give you a bit of context on what's happening there. So now I'm going to talk about serverless and what's happening there. So Lambda adoption is really growing very fast. There's hundreds of thousands of customers, trillions of Lambda executions every month. We have a very large number of customers that are using serverless, just a few of them there. But so why are people building serverless applications? And it's really for agility, performance, cost, and security. And I think the work I'm doing right now is to research the carbon footprint of it as well, because I think it's also the most sustainable way we can build applications. And we chose microservices to get speed and agility, but how long does it really take to build a new application from scratch? And I had one of those light bulb moments when I was a judge at a hackathon. And in 12 hours, every team had to go build something. They didn't know what they were going to build until the beginning of that period. And many of them, it was the first time they used Lambda. And we were amazed by what was produced in basically a day's work by a small team of people. Extremely functional and scalable prototypes built on top of Lambda and the off-the-shelf serverless services that you glue together with Lambda. And what we found since then, many more examples of this, serverless app development isn't an incremental change. It isn't 10 or 20% more efficient than building something some other way. It's a complete reset. It's an order of magnitude better. It's 10 times faster. Often it's a tenth of the cost if you're doing it right. There's many examples now where it's faster and cheaper, and it's an incredible difference. So why doesn't everyone use serverless first? So I'm going to go through all the reasons I've come up with why people think that they shouldn't be using serverless, and then sort of look at what's happening. Basically, how do we address those concerns? So here's just a list of those. I'll go through these in turn. So we started off with AWS Lambda really just did JavaScript, but now it's got all of these different languages built in as standard. And there's a bring your own language runtime API. So if you have your own custom weird language or whatever you want, you can go and add it to serverless as a supported language. And then a bunch of third parties have come up with direct support for languages, Rust, PHP, Erlang, COBOL, even COBOL and Fortran. So it's pretty easy to get whatever language you want supported by it. Then there's the scalability. When we first launched, we had a default concurrency of 100. You get 100 CPUs. Now the default is 3,000, and you can ask for more. And there are some customers now getting up to approaching 100,000 concurrency for a Lambda function. So I have a single Lambda function. I'm going to get so much traffic on it. I want 100,000 machines running that Lambda function. That's an incredibly powerful computer that's just available by just turning up a limit, not having to worry about it. Now, one of the problems that people were running into was the size of a Lambda function. We originally, we limited it to 512 megabytes, but there's two ways of solving that. One I'll get to later, but one of them is just to mount an NFS file system, and you can have petabytes of data. This is particularly important for people doing machine learning inference. A lot of the models they produce are gigabytes in size, and you want to have a Lambda function mount and load a multi-gigabyte machine learning model. It was too hard to package that within the function using the old method. So you just mount it and share it and do it that way. Startup latency is something we've been working on for a long time, tuning it down. But we've also now got pre-provisioned concurrency. When you run a Lambda function, there's an initialization phase that gets run once, and then events get given to that function to be processed. If you're running say a Java application, a JVM takes a long time to start up. So you run that once, and then your Java processing is usually pretty fast because it's well optimized by that point, and all the just-in-time compiler and everything's kicked in. You've loaded all your jar files and you've initialized all your data. You can spend minutes doing an installation, provisioning a Java Lambda function, but then you can be running things in milliseconds for the individual calls. So with provision concurrency, you can say, I want to pre-initialize some functions because I know I have a huge spike in traffic that's coming. it's going to be a flash sale, and it's going to be like an enormous number of customers turning up at a very specific time. You can do things like pre-initialize for that. Now, you may read old blog posts about network setup taking a long time. That was fixed almost 2 years ago. So private VPC networks isn't an issue anymore. A few other things we've done. We keep increasing the amount of memory in CPU. So you now have 10 gigabytes of memory and 6 cores per Lambda function. So that gives you a huge machine. If you think about tens of thousands of instances, each with 10 gig of RAM and 6 CPUs, that's just an enormous machine that you can create very simply. EFS I've mentioned, provision concurrency. And then, we are running this thing at enormous scale. It's running in the millions of transactions per second as a service, and we just keep improving it all the time. If we think about routing traffic to Lambda, one of the criticisms is that you spend more sometimes on API gateway than you spend on the Lambda function that sits behind it. So we did some work on that to improve reduce the cost and have faster transforms for API gateway. We also provided the option to use ALB for simple Lambda path-based routing. Gives you more throughput at a lower cost. The other thing is, if you're making lots of little API calls, you may actually want to think about re-architecting your application to use AppSync and use GraphQL. So you send in many, many fewer API calls. You send in a request. That request is then sort of explodes into lots of internal calls to generate the result, and that complex result object is sent back in a single request. It's much better for the long distance latency to the cloud from your customer, and all of the chatter happens within the system with a whole group of Lambda functions collaborating to generate the GraphQL response. Another thing we did just a few months ago was move to 1 millisecond granularity for Lambda. So you're paying by the millisecond now. Didn't have to do anything to adopt that. It just happened. And then from the security point of view, every function is running in its own virtual machine using our Firecracker virtual machine manager. Initialized Lambdas are only reused for the same account. There's no open ports. There's a minimal attack surface. And those functions are recycled after a few hours. You never have to patch a system, because if some CVE happens and there's a 0D, there's a big problem, we send through a message saying, here's where you download your new base images for EC2. Here's where you get your new container images. Here's your new operating system versions. If you're running Lambda, forget it. We've already fixed it for you. Don't worry about it. Within a few hours, you'll be running on a completely patched infrastructure. There's a number of ways of securing workloads. We've also added some additional controls to VPC so that you can manage access a bit better. We've got some well-architected focus on Lambda as well. And then we recently came up with code signing. So you can now deploy signed code from trusted sources and separate duties between operators and developers if you need that. Now, Lambda is really it's a functional model, and functions are intended to be stateless. So people think, well, how do I build state into my Lambda system? Well, there's a few ways of doing it, but step functions is a state machine that integrates very closely into Lambda. So you can start a flow, you can have it run for a year, so up to a year. So this gives you the ability to say, start a flow with a customer or a customer sign-up flow. There's a lot of back and forth and emails going out and the customer acknowledging and confirming their email address. Perfect for creating those kind of things in step functions. We've also seen a bunch of people doing step function first development. They figure out what is the business logic for the flow of things they need to build, and they build that with Lambda and with step functions, but with Lambda providing the hooks and the API calls, and with step functions providing the flow. And when we first did this, it was relatively slow, and people said, well, this is kind of a toy, you can use it for some things. But since then, we've increased the performance and reduced the cost. So we now have 4,000 steps per second easily available. And we also came up with Step Functions Express. This gives you over 100,000 events per second for flows where the flow itself runs for less than 5 minutes. You can use this within a lot of data lake environments where what you want to do is pump data from one S3 bucket to another, and you want to provide the same transform to every one of those pieces of data. And you want to run a function across a complete set of data. So you can use step functions, express workflows to pump data through like that. The duration we've increased from 5 minutes to 15 minutes. If you need longer than that, you need to use batch or Fargate to create containers. So one of the things that, we can't use this for everything. One of the things that you might want to do is use very specific instance types like GPU hardware. It turns out it's very difficult to integrate GPU hardware into Lambda. We haven't figured it out yet. And it's difficult to share a GPU across very many virtual machines in a very lightweight way by the millisecond. So that's something that's still being worked on. So you use longer running containers to build these parts of your workload if you need it. Now, if you're looking at event processing, there's an enormous number of ways of doing this. Data streams, there's dead letter queues, there's Lambda destinations. So this is where individual services, rather than making an API call to talk to them, just send a Lambda event because they understand they have a Lambda-based interface. Lots of controls for building stream events, and then we came out with Eventbridge, which gives you a way to send a single message and then fan out to collect data. So you might use this in a GraphQL backend, use Eventbridge to take the initial request, and use Eventbridge to fan that out to all the individual services which need to gather up, all the microservices or functions which are going to gather up and provide the result that comes back in again. Now, another criticism is SQL databases. They can get overrun by Lambda functions. So one of the things you can do is have per function concurrency limits. So basically, if you have a database like MySQL or something like that, which has a number of threads that's configured in it, then you want to limit your concurrency so that you don't overrun that. But also we now have an RDS proxy for connection pooling and failover. This also uses secrets manager, so your code doesn't have to worry about having credentials in it. The credentials are in the proxy, and that gives you a clean way to access into databases. Much nicer way of doing it. Then if we look at more complex production use cases, some people now have thousands of different Lambda functions that make up their production workload, and they need to gather all this together. Turns out that what you really need here is to use a parameter store. You need to use environment variables. You need to use KMS to manage your secrets, avoid hard-coded credentials. There's a number of things that you want to do to wrap around this. And you want to use Lambda layers for your common code base that you have across multiple Lambda functions. So this lets you build reusable modules for common parts of your system. Now, another thing is portability, a common criticism. Now, if it takes you a week to build something with Lambda that's going to take you months to build some other way, then maybe you can just build it twice. And you can probably build it in less time than you spend arguing about how you're going to configure Kubernetes and do all of the other things you might want to do. And maybe you can, there's time to build it twice. So now you build a portable Lambda app by building it on Lambda and building it on one of the other serverless cloud platforms. And you've got a portable serverless system, and you've still spent less time than you would building it another way. So that's one way of thinking about portability. We've also been working on integrating into the container world. And a lot of people have a container-based delivery pipeline, CI/CD system, and tooling. So one of the things we've done is let you package your Lambda functions using the same pipeline. So you don't need to build a different CI/CD pipeline for your functions than you do for your containers. And this lets you do 10 gigabyte images, which is another way that you can package machine learning models and things like that into your system. So there's a lot more going on in portability, a lot of open source tools that you can use, a lot of other frameworks, and then there's some other cloud providers that also have serverless environments. So it's getting easier to figure these things out. Another thing, debug tools, lots of work going on here. There's tools from AWS and from third parties. And then we have this new extensions interface. So now within your Lambda service, you have the API itself, but you also have the extensions API, and running as kind of like a sidecar with the Lambda function, you now have the extension from Datadog or HashiCorp or whoever's your monitoring function provider. Another area is patterns, like you want circuit breaker, you want webhooks, you want fan outs. There's a lot of good work that Jeremy Daly's done on his blog, and there's a few other patterns that you might want to look up there. Lots of good work there. How do you get started? We've been putting a lot of effort into this, both building CDK support, frameworks, and building a simpler way to get started. But SAM CLI is one of the main ones, doing a lot of investment in this recently. So you can use SAM to create your things, and you can also use CDK to provide the configuration. That's the Cloud Developer Kit. So you can combine together all the things you need into this. There's a bunch of pre-shared, pre-built serverless functions. You can get them from the serverless application repository. So I just went through very quickly all of these different object things. And if there's something on here that's still blocking you or something that isn't on this list, then tell us about it, because we're probably already working on it. So I'll talk very, very quickly about a customer, Liberty Mutual. They've been doing an awful lot of work in serverless first. They've also been doing a lot of work in CDK, and they sponsored the CDK Day. And they've been sharing a lot of their patterns at cdkpatterns.com. You can go watch the videos. Lots of useful things here. A lot of well-architected patterns. One of their applications is a monthly job they run, which gathers all their businesses from all around the world, and it's a batch job that consolidates 100 million transactions. And it doesn't exist for most of the month. It just runs when it's needed. It always has the right scale, and it costs $60 per million transactions to run. It costs so little that they just don't need to think about it anymore. If we look at existing workloads, we need to reduce the amount of DIY, migrate, and modernize. There's a few things that we've been doing to make that easier with MQ and MSK, for Kafka, and Airflow. So Airflow support, lots of useful work here for producing managed workflows, lots of good integrations that you can build. And finally, we have Proton, which is a way to set up kind of the guardrails for say, an operational architecture that you want to create patterns that development teams can just plug into. So this is around just managing that deployment service. So serverless, as I said, is about innovation, increased agility. We've got more performance, we've made it cheaper, and we've got a really comprehensive portfolio of services. To the bottom line, I really think this is the fastest way to build a modern application. And if there's something that's blocking you, let us know what it is. So that's what I had. Talk about serverless first, and I think also the most sustainable way that you can build applications nowadays. So thank you.
Hey, thank you very much for your talk. It was a very nice talk, and I even have some of the questions myself. But let's see what questions do we have in the question and answer section. And also, I would like to invite everyone to rate the talks in the poll. Questions from Johan. What is your thought on the dependency created between an application and a serverless infrastructure provider? His fear is that I become too tied to one provider in a particular way, and the shift is not trivial.
Well, I think that the alternative takes longer. So as I mentioned, if you can build something in a few days serverless, yeah, it's tied to that provider, then you build it again in a few days with another supplier. Your architecture and your thinking about the product you're building will be shared. Most of the work now is trying to figure out what we should build. The implementation of it is getting to be less and less work, and the cost of running it is becoming less and less. It's much more about figuring out what you want to build. So I think building this once on AWS and again on another cloud provider is actually going to be less work than building a portable thing where you're doing all of the work yourself. That's one way of thinking about it. And there are some frameworks that will make this a little bit easier, like the serverless.com. There's a framework there. There's a number of things you can do to make the tooling a little bit easier. So if you know you're going to be building this across multiple cloud providers, there's some tooling to help you make that a bit simpler.
Okay, so thank you for the answer. Serverless.com, maybe one page to remember. Another question from Christoph. What's your prediction on how serverless computing services will evolve in the future? What changes are to come soon, and what do you expect to happen in the long run?
I think that we're on a path where the latency is getting lower and lower. We have more work to do there. If you have a very intense, very high throughput workload where it never goes to zero, there's always work to be done. It's still more efficient to use a container-based auto-scale system for that. If you're doing something that is, say, ad serving or a very real-time workload where the time taken to respond needs to be as short as possible, again, you'll want to connect directly to a long-running service. And what I think will happen over time is that fewer and fewer people will need to do that. We're going to get that latency to be short enough that it just isn't worth putting the effort in. And the overhead, the efficiency of running serverless is just going to keep going down. So I think it's a very clear path there to make it more efficient. And then the other thing that I'd like to see, I mentioned briefly, we don't have support for different instance types and GPUs and things like that. I think we need to kind of broaden it out so that all of the very broad range of instances that are available on AWS become easier to include in there. But I say these are kind of long-term directions for things that we're looking for, and if there's something that you think you need, certainly we want to hear about that, because that really drives our roadmap. Mm-hmm.
That's an invitation for dancing, right? So please put it on also into the chat. So if you are thinking about something on serverless, and now I'm talking to all of you listening, that how can it be better? How shall it evolve? Then I think these are the right occasions to discuss this kind of questions. Thank you very much. Let's check the next question, which is from Gabor. On what facts, statistics do you base the claim that with serverless you can build your application 10 times faster?
I've just seen lots of examples. You're writing a lot less code. So the example from Liberty Mutual, they have entire teams that are building now so fast that the product managers are the bottleneck. Right? They can't think of new things to do fast enough to keep the teams busy, which is unheard of. The project managers are complaining at the developers normally. So really you can build something in a few days. If you're not doing it in a few days, then there's something else that's slowing you down. It's not your development environment and your platform. It's something about the way you do business, because we've seen this at all these hackathons, that you can assemble an extremely complex system which will scale to production because you've built it out of components that work already. Like you've got your databases as a service, all of the serverless. Think about serverless as gluing together all of these really reliable long-running services. That those parts work, you just have to connect them together to make your application. Mm-hmm. If you're coding all of this up and you're having to install it and you're having to build all these pieces, that's what takes a long time. So yeah, it is possible to build things quickly. In other ways, it's just a lot more work and a lot more setup time to get there. With serverless, if you just drop yourself straight into it and just start building, you'll find that you can build things incredibly quickly with whatever your favorite language is, and the environment just gets out of your way, and everything is sort of taken care of for you. So I think we just have lots of examples showing that things are built very quickly, and then they cost very little to run, particularly workloads, corporate IT workloads, which are very driven by people and when they're at work, and when they go home, there's nothing happening. Those workloads are incredibly cheap to run. And the other one is around operations automation. A lot of people do their operations automation with scripts. Some of the scripts are polling for things to happen. You should be being event-driven Lambda functions. So when an instance appears in your environment, that event causes a Lambda function that does some configuration to set it up, or maybe when something goes away. Like if an instance disappears, you have to clean up after it. You take that event, you feed it to Lambda, and that cleans up, attached volumes or anything like that. So there's a bunch of ways that people are starting to use event-driven operations automation based on Lambda and step functions as well.
Mm-hmm. Thank you very much. I really liked your statement that sometimes the developer teams are faster than their product owners or project leads. That I rarely see it in regular development cycles. So thank you once again for the nice talk. Let me just show you a small present. I hope you recognize yourself. This is a fun picture of you, and this is a mug we will ship to you, so you can enjoy coffee or tea next time using the mug. So we really appreciate your presentation, and thank you very much for being with us today. This was our last talk today. So everybody, please, one more applause to ADRIAN. Even if not so many people. I mean, it's much more better, when everybody's gathered in a big room and you get a big applause, but now it's me doing it.
Okay, well, thank you very much. Thank you for putting this together, and best wishes for keeping Craft going, and hopefully see you again in person at the next time.
Yes, we hope so. And by the way, the conference has not ended for today, although this was the last talk. I just want to say that there is a platform called wonder.me, which you can use for further socializing. You can also stay on Hopin, and you can ask questions in the chat, go to the breakout sessions, and visit the booths or whatever. And there will be some activities as well. So the organizers are trying to make some social event as well out of this conference. And one is there will be a bartendering course, which you can join through a Zoom link. It will be shared in the events chat. And there will be a quiz night, which you also can join with a Zoom link, and I guess with a beer. And that will also be shared in the events chat. There will be also karaoke. So I don't know how to karaoke through the internet. I tried online music, but not my style. I'm a musician, by the way, so I rather play in the pubs than at home in my photo. But this is me.
Look at the music. There's my musical stuff lurking behind me. There's some guitars.
Nice one.
I think PowerPoint, isn't it PowerPoint karaoke?
It's PowerPoint karaoke. Yes.
Yeah, that's fun. I've done that a few times. Yeah, where somebody else makes a deck and you just have the deck. A slide appears and you have to just say something about it. And they make decks that try and trip you up or try to be amusing, and so it's very entertaining.
That's one I will try out.
We've had some fun doing that.
Yeah, sounds really great. So I would encourage everyone to join these social sessions, and thank you once again.